All right, this video is going to spill the tea conceptually on RC circuits. Let's back up a little bit and talk about how a capacitor works. A capacitor is basically two parallel plates separated by some distance, sometimes with a dielectric in between them. These two plates are connected to two sides of a battery in the simplest case. And I've got a switch right here that's open. What I'm going to do next, I'm going to close the switch. When I close the switch, charges will travel from the battery down to the plates. So let's talk about the directions of the current. I'm assuming the conventional definition of current. That means I'm going to obey the second law of thermodynamics, which says that energy always flows from high potential to low potential, or the plus side of the battery to the negative side of the battery. Because potential flows in that, because energy flows in that direction, then I need charges to flow in that direction. Therefore, I'm going to assume that in the conventional definition, positive charges are flowing out of the battery. I know in reality it's the electrons, but in the conventional definition, we pretend there are positive charges coming out of the positive side of the battery. So the positive charges are coming out of the battery and they're flowing onto the plates. And that's what generates a current, the flow of charge. Then the charges begin to build up on the plates. First, I'll get a positive charge on the left plate, and that will repel a positive charge from the right plate to go to the battery, leaving behind a negative charge. And then the same thing will happen here, and another charge comes on, another charge comes on. So physically, charges are beginning to fill up on the plates. This is called the transient state. That's when that first charge comes onto the plate, right there. And it lasts for less sound than a hand clap, so a very small amount of sound or amount of time. That's all the transient state is. And then I'm in a transition state, which we're not really going to focus on until I get to something else called the steady state. So after a long period of time, the plates become full. And when they become full, the current now disappears because there's no more charges. There aren't any more charges flowing through the wires, so therefore there's no current in them. This is called the steady state, and that's over a large amount of time we get into the steady state. Transient state is that instant when we first connect the switch, then we have a transition that we're not talking about right here, and then the steady state is after a long period of time, I get to where the plates are full and charges aren't moving and the current is zero in the circuit. So when I add a resistor, this is called an RC circuit, a resistor-capacitor circuit. And here are some examples. The three top and the three are all parallel. The order of the resistors, the batteries, and the capacitors do not matter. And then I've got a little parallel circuit at the bottom. So series at the top, parallel on the bottom. And when I look at these circuits have two personalities. So I think of them as Dr. Jekyll and Mr. Hyde. And they operate two different ways. So what do we need to know by the time we're done with all these videos? You need to know what happens to the voltage across the resistor and the capacitor and the current through the resistor and the capacitor in series and parallel circuits during the transient and steady states. Wow, a mouthful. That's a lot you got to keep in mind. Let's see if we can do a lot of this by reasoning it out, what's happening. I'm going to look at a series circuit first. I mentioned two personalities, Dr. Jekyll and Mr. Hyde. So Dr. Jekyll is the transient state when I first turn it on, and Mr. Hyde is the steady state after it's been on for a long time. So I close my circuit, click. Now at this point, just at this instant in time, basically the capacitor is not part of the circuit. It's not affecting anything yet. I haven't quite put a charge on there yet. But at this point, it's all about the resistor. So don't worry about the capacitor, it's just about the resistor. So this is the Dr. Jekyll part of my circuit. So in the transient state, there are a couple things. First off, the capacitor's resistance, which is really called impedance, but resistance is zero. And it's zero in resistance because nothing's happening, nothing's going across. There's no resistance to the charges piling up on the plates yet. The currents through the resistor and the capacitor are the very same because the two components are in series. So the current is equal to the voltage, that's going to be the voltage on the battery actually, divided by R. The voltage of the resistor equals the voltage of the battery at this point. Now, in the transition period, it'll be decreasing, but we don't need to worry about that. At this point, the current is also beginning to decrease over time as the capacitor fills up, the flow begins to slow down. So as charges pile onto the plate, the charges that are on the plate already are repelling charges from coming onto the plate. And so it becomes harder and harder to add charges to the plate. So inside in this transition period, there's beginning to be some kind of resistance going on. Now, that's just kind of giving you the fill-in of what's happening in between, but all I really care about is what happens at this point when I first turn on that switch in that moment of contact. So let's say the circuit's been connected for a long period of time. So a lot of time has gone by. Now, at this point, the capacitor is filled up with charges, and because it's filled up with charges, it cannot accept any more charges from the battery. If it cannot accept any more charges, there's no more current coming through the circuit. If there's no more current, then because the voltage across, or the potential difference across the resistor is equal to I times R, if I goes away across the resistor, which it does, then there's no more potential difference or no more voltage across that resistor as well. But don't be tricked just because there's still voltage in the capacitor, because that's what the capacitor does, is it stores up energy. And the voltage is determined by the ratio of the charge in the capacitor divided by the capacitance itself. It has nothing to do with the current. So all that voltage is in the capacitor this time. So in the steady state, the capacitor's resistance is basically infinite. In other words, it stopped the flow of charges going from one side to the other. The current is effectively blocked by the capacitor. So the current is equal to 0 at this point in the entire circuit. The voltage on the resistor is 0 because there's no current, because the voltage across, or the potential difference across the resistor, is determined by current times resistance. Therefore, the capacitor has the same voltage on it as the battery itself. All right, that's kind of the short shrift of RC circuits for series circuits.